Hi, we have the AP Physics 1 past paper 2021. We are discussing free response question. We have the question number 5 which carry the 7 points. Two pulleys with different radii are attached to each other so they rotate together about the horizontal axle through their common center as shown in the fig. There is a negligible friction between the axle. Object 1 hangs on the light string wrapped around the larger pulley. So M1 is the lighter mass or the smaller mass with connected with the larger pulley which has the radius 2 or not. Okay. Now the object to hang with the another light string wrapped around the smaller pulley. This is the bigger mass as compared to this one, but it's connected with the smaller pulley as shown in the fig. The m naught is the mass of object 1.5 m2 object of mass m2 r naught is the radius of smaller pulley 2 r naught is the radius of larger pulley. Now question is at time t0, pulley released from rest, object begin to accelerate. Drive the expression for the magnitude of net torque exerted on object pulley system about the axle after pulley are released. Express your answer in term of m naught, r naught and the physical constant as appropriate. Okay. Now we have the two objects, both are moving with their respective motion. So I have placed just like the M1 has the counterclockwise direction. So its torque can be calculated with R into F. We have R 2R. It's M naught G is the force that is pulling downward. So 2R naught M naught G is the torque due to larger pulley. Okay, object 1. So torque due to object 2 on a smaller pulley that's moving to the clockwise direction. So there is the again R into F. R is R naught mass force is m1.5 m naught g. The torques are in opposite direction. I have placed the positive for counterclockwise direction and negative for clockwise direction. So T1 minus T2 because if you find the right hand rule, the thumb goes upward. Upward is taken y-axis positive. So conventionally counterclockwise torque take upward torque is taken positive or downward torque taken as negative through right hand rule. Okay. So that's the reason T1 minus T2, the difference is 0.5 R naught M naught G is the net torque acting on a system. Okay. Object 1 accelerate downward after the pulley is released. Briefly explain why. So object 1 exert a greater torque to R naught M naught G as we have calculated there. Object 2 have 1.5 R naught M naught G. Since counterclockwise torque is stronger, in system rotate in that direction causing the object 1 to move down. So this is the reason the object 1 move down or accelerate because it exerts the greater torque on this side. Okay. Now the later time that t is equal to delta c string of object 1 is cut while the objects are still moving, the pulley is still rotating immediately after the string is cut. How do the direction of angular velocity and angular acceleration of the pulley compare to each other? Both are in same direction or both are in opposite direction? We have the answer of they move in opposite direction. Now the reason why before the cut t is equal to tc, system is moving with the object 1 descending and object 2 ascending as we have discussed in the previous case. The object 1 has the stronger torque so it moves the object m1 downward and so it moves the upward. So now the angular velocity inertia keep it spinning in the same direction. Angular velocity is still counterclockwise. Angular acceleration, there is no more torque from the object 1. Only remaining torque is from object 2. Object 2 pull the clockwise direction. This direction is opposite to the original rotation. So that's the situation. Hence, what's the answer? Pulley is still rotating counterclockwise, but only remaining torque causing the angular acceleration in opposite direction clockwise, causing it slow down. Okay, that's the answer. Now, next part of the question is on the axis below, sketch the graph of angular velocity omega of the system consisting of two pulley as the function of time. Include entire time interval shown. The pulley are released at t is equal to 0 and string is cut t is equal to tc. Okay, we have to show what happened to the change in angular velocity with the function of time. From we have divided is two pattern from t is equal to 0 to t is equal to tc after that. So from T0 to T is equal to Tc, net torque is constant. We positive, we have 0.5 R naught M naught G. So acceleration is positive. It's mean omega increase linearly with the time. So this create a constant positive slope. Graph should be straight line starting from the origin and increasing. You are saying from this to this region. There is a torque which is positive in like that, the constant torque which is representing here, because then our external torque is constant and positive. Okay. Now what happened after T is equal to Tc? The string is cut. The torque suddenly changes. Now that's from 0.5 R naught mg, that is the net torque before the cut. It only remain minus 1.5 R naught m naught g. The pulley now experience the constant negative torque. Alpha is negative, mean omega decreases linearly with the time. The graph becomes the straight line with negative slope. It heads back toward the x-axis, slowing down until it reaches zero and then goes to the negative, mean change its direction. So that's the how happen when the string is cut. Only object 2 is acting there. So that's what happen to the result to the whole system. So that's the answer. If you have any query, kindly ask in a comment. If you like the content, kindly subscribe and share it with your friends. Okay, take care.